All right, hello everyone, and welcome to the International Workshop on Cross-Reality Interaction. Thank you all for making it today. So we have, I think, more than 34 people on Zoom at the moment, and there are also others watching on the YouTube stream. So we have a very exciting program today, thanks to the authors who will present and our keynote speaker, and we've planned also some exciting group activities. All right, so I'm going to keep this opening short, just spending a few minutes to introduce the people involved in the workshop. So, this is our organization team. So each of us now will briefly introduce themselves in 10 seconds or less. So Adalberto, would you like to start? Not sure if Adalberto is... Okay, so then I'll just start then. So yeah, my name is Mohammed. I'm from the University of Glasgow. So I'm interested in interaction modalities for cross-reality and also in the privacy and security in mixed reality applications. Matthias, would you like to go next?
Mute myself. Oh, I can unmute myself. Hello. So my name is Matthias Klion. I'm coming from University of Primorska in Slovenia. We are co-directing the first HCI lab in the country together with my colleague Klen Čopić-Pocihar, and I'm also chairing the current ACM CKI chapter in Slovenia. And my research is, well, it's generally HCI, but the majority of work we do nowadays, it's in augmented and virtual reality.
Adalberto, I think you're online now. Could you go next?
Yes, sorry, my microphone was, I don't know. Anyway, I'm Adalberto Simeone. I'm an assistant professor here at the Department of Computer Science at the University of Leuven in Belgium, where I'm leading the ARIA team, which is the research group on artificial realities and interactive ambience. And as the name implies, our research focuses on virtual reality and other immersive technologies, which is one of the reasons for this workshop. Yeah, so that's me.
Thank you. So Poika, could you go next?
Hello, so I'm Poika Isokoski from the University of Tampere in Finland, or presently I'm in a storage room at the back of my house. I'm currently a staff scientist responsible for a lot of laboratories where we do XR and VR and AR work in Tampere. Thank you.
Thank you. Augusto, would you like to go next?
Hi, I'm also assistant professor here at the University of Lisbon. I lead the HI lab, and we deal with sort of nuts and bolts kind of research on this area, and more recently in this area of AR, mixed reality, and VR. And we're here engaged with Interactive Technologies Institute here in Lisbon, and happy to be here.
Thank you. Florian, would you go next?
Hi there, I'm Florian Daiber. I'm a senior researcher at the German Research Center for Artificial Intelligence in Saarbrücken, Germany. My main research field is very broad nowadays. I'm mainly doing HCI for 3D user interfaces for VR and AR, but also interested in wearable and ubiquitous computing, mainly in the field of health and sports technologies. Especially there, we started with a lot of XR-related work, but not only. So I'm also interested in industry and retail application areas, which we are doing lots of applied research. Good, I think that's it.
Okay, thank you, Florian. Glenn, would you like to go next?
Hello, my name is Glenn. I come also from Slovenia. I'm assistant lecturer at University of Primorska, where I co-direct an HCI lab with Matthias Klion. My research focus is in finding new ways to use computational resources to progress our human abilities to interact with digital worlds, where the main focus is in XR technologies.
Thank you. Jan, would you like to go next?
Oh, now I'm unmuted, right?
We hear you now.
Yes, we can hear you.
Okay, so my name is Jan Guggenheimer. I'm an assistant professor at Telecom Paris / IP Paris here in France. And similar to, I think, most of the people I'm working at the intersection of HCI and mixed reality, I did some work on asymmetric interaction for virtual reality. And most recently, I'm exploring a little bit negative implications, harmful impact of augmented virtual reality.
Okay, that's great. So thank you very much. And next, of course, like big thanks to the members of our program committee who volunteered to review the papers. So they had to do the reviews in a relatively short time frame. So we really appreciate their contributions to the program. So I'll see if clapping works in Zoom. So we received in total 13 submissions, and 8 of them will be presented today. Each paper received 2 reviews by the organization and program committees. So from the papers, we see that there's a lot of interest in cross-reality, and there are also diverse interpretations and takes on XR, which I think will contribute to make this workshop further more interesting and exciting. So yeah, looking forward to the discussions phases. And yeah, there are also many ideas for creative applications using cross-reality, which is also very exciting. So this is a glimpse of our program today. So we will start by the paper presentations, and after that we will have a break. There will be then the keynote talk by Dr. Anasol Peña-Rios. She's an expert in using immersive technologies to advance solutions for real-time support, collaboration, and training. Augusto will give a longer introduction right before the keynote talk starts. This will be followed by another break, and then we will start the group activities. At the end, there is a social gathering online, so stay tuned for that. Also, Adalberto will give more information about this later. This is a list of the papers that will be presented today. You can find the list on the website as well, and the PDFs as well. The presentations will start now, so we're going to have 2 presentation blocks, each with 4 videos and 15 minutes of Q&As. You can participate in the Discord channel or on Zoom. So on Zoom, you can do it through the chat, and on Discord, perhaps if one of the organizers could paste the link to the Discord channel here, I think that would be helpful. And yeah, there will be a live Q&A part for each block. So if you want to ask a question, you can raise your hand or using the feature on Zoom, or you can write your question here in the chat. All right, and then now I will hand over to Florian, who will play the videos.
I'm taking over, just a second. Sound, don't forget the sound. Okay, without further ado, I would just say let's go.
Welcome to my talk on cross-virtuality visualization, interaction, and collaboration. My name is Andreas Riegler, and I'm a researcher at the University of Applied Sciences, Upper Austria. Virtual reality. Instead of interpreting numerical or symbolic outputs, interactive visualization allows the use of human input for visual information processing and pattern recognition in order to discover and understand trends, patterns, and correlations in large amounts of data. Interactive visualization and the data analytics process are best supported with technologies leaning to the virtuality side of the reality-virtuality continuum. Nonetheless, smooth transitions towards the reality side of the continuum can play a critical role to integrate data analytics into real-world spatial settings and social environments, such as physical movement in a familiar work environment or face-to-face collaboration with co-located team members. In order for immersive analytics to be used to its full extent, traditional 2D desktop environments and virtual environments must be seamlessly combined and integrated. Technologies and media used in the field of immersive analytics on the reality-virtuality continuum offer individual advantages and disadvantages. 2D visualization on touchscreens allow for familiar visual representations, directness of touch interaction through haptic feedback, very high readability, and very high resolution. Furthermore, 2D visualizations provide the opportunity of natural collaboration, especially on tables, walls, or multiple tablets for collaborative visualization using tangible interfaces. However, 2D visualizations lack stereoscopic representation, which leads to a low level of immersion. Augmented reality allows for the retention of the natural environment, stereoscopic presentation, natural spatial navigation via body movement, spatial organization of content in the physical environment, object reference data representation, and integration or representation of remote users. However, AR still provides a limited field of view and poor contrast. Virtual reality allows for stereoscopic presentation, natural spatial navigation via body movement and head tracking, spatial organization of content in any size of virtual environment, significantly larger field of view, and integration or representation of remote users. However, users are visually and socially isolated from the real environment, and interaction with content does not occur via familiar touch interaction, including haptic feedback. The possibility of targeted movement within the RV continuum creates a unique new tool for the exploration and analysis of data. For example, at the beginning of the analysis process, a collaborative visualization of data in 2D for all team members on a non-stereoscopic interactive wall with touch input and pen input is possible. Head-mounted displays can also be used to freely place stereoscopic 3D representations of the data outside the wall display in the room, for example to enable collaborative analysis of additional dimensions by some team members by means of physical navigation with their own body. Using AR, the physically present team members remain visible, and further data, visual metaphors, or even additional team members connected via the internet may be integrated in the room using virtual representations, for example for telecooperation. Should the analysis of the data require a larger field of view and the fading out of the real physical environment, this can be realized at any time using VR head-mounted displays. For newly researched methods and procedures of cross-virtuality analytics, it is essential to ensure a spatial and semantic orientation of the users during these transitions between reality, augmented virtuality, or virtual reality via perceptual and cognitive anchor points. For example, the preservation of spatial landmarks across different media is desirable, so that physical objects such as screens are not only visible in reality and AR, but also appear in VR through correctly placed virtual representations. Furthermore, the transition has to be fluent and keep the users focused on their tasks. The impact of collaborators during the transition process has to be considered as well. This also applies to the presence of real or virtual team members in the environment. Cross-virtuality analytics is also highly attractive for gaining deep, previously unimaginable insights into rich volumetric data. Current challenges in this area focus on integrated visual analytics, quantitative data visualization, visual debugging, and visual steering. Cross-virtuality analytics yet plays a minor role in this area, but contains a tremendous potential for future applications. Thank you very much. With technologies leaning to the virtuality side.
Good day, everyone. We are here to present our paper entitled Sound 2121, Cross-Reality Transitions Between Real and Augmented Sound Landscapes. We are Jordan Icodea, Nuanti Atigale, together with our supervisors, Klen Chopic Putsihar and Matyas Klun. We are from the Hiccup Laboratory of the University of Primorska in Koper, Slovenia.
Music and sounds have always been an integral part of our society since the prehistoric times. However, music listening has moved from a social experience to a more personal one with audio systems such as speakers moving ever close to our ear canal. Based on this pattern and various futuristic visions of how we are going to listen music, one can start to imagine a situation where a chip in our auditory cortex will stream sounds directly to our brain. However, augmenting our hearing with objects around us capable of streaming sounds directly to our brain might exacerbate the already present problems of blocking the environment sounds and not paying attention to what is happening around us. In this positional paper, we discuss not only what is the future of music listening and how will we consume music 100 years from now, but also how are we going to enable users to pay attention to their environment and enjoy music listening at the same time. Put differently, how are we enable users to constantly switch between the real and augmented sound landscapes and enable seamless cross-reality transitions as well as preserve a positive user experience. One area of cross-reality interaction explores the shift between multiple systems on the Milgram's Reality-Virtuality Continuum. In this position paper, we envision a future with a chip-to-brain sound transmitting interface that allows interaction between and mixing of multiple sound realities and virtualities from the environment sound to music listening. Our position diverts from the typical visual augmented and virtual reality, but rather focuses on the problems of sound and how humans transition between different sound sources. We intend to share a perspective that may consider also the transitions induced by visual elements, augmentations, and virtual worlds as they are consumed with sound. This paper also encouraged several questions, such as how to retain users' attention, task awareness, and even social communication while interacting with the environmental sound as well as the streamed one. Switching between the environment sound to augmented streamed one. Today's headphones are complex small devices that are capable of actively and passively cancelling environment noise in order to enable users to be uninterrupted while listening to their favorite tunes. In earbuds, even mechanically, block outer sound from entering auditory canal. While these might be desirable features on some occasions, they are also problematic since the sounds from the environment provide a cue of what is happening around us humans. Humans always relied on these sounds in order to survive. However, seeing a cyclist or pedestrian or a car driver with the headphones on is not an unusual sight and greatly affects users' situational awareness. Since music has helped humans throughout the history in terms of survival, forging a sense of group identity and mutual trust, since environment sounds landscape help us being alert and safe, we need to enable their roles in the future as well. Be it in physical environment or in any mix of reality and virtuality. At the same time, we need to avoid the polluted sound landscape as in the video of the hyper-reality vision of the future, visible on figure 2, where adverts and services seek our attention via visuals as well as sounds. And imagine receiving this through our brain chip interface and transitioning between the reality only and hyper-reality.
In this position paper, we tried to raise a few significant and relevant questions involving cross-reality. And we hope that you guys will read our paper and provoke discussions in this workshop. Once again, thank you for listening. And this is again Sound 2021 Cross-Reality Transitions Between Real and Augmented Sound Landscapes. Thank you and have a nice day.
Hi, my name is Jonas Auder from the University of Duisburg-Essen, and on behalf of my colleagues Uwe Grünefeld and Sven Meyer, I'm going to present our work, which is titled It Takes Two to Tango: Conflicts Between Users on the Reality-Virtuality Continuum and Their Bystanders. The core idea of our work can be illustrated with a simple example. In this picture, we can see a user who is immersed in a VR application. Somehow, the user is challenged by a specific task and states that help is needed. The bystander offers help to the VR user but does not see what is the issue. Because both persons do not share the same reality, we see several issues arising due to perception differences. To better understand these conflicts, we can look at the Reality-Virtuality Continuum, which was introduced by Milgram and Kishino in 1994. To recap, the continuum is spanning from the real environment, here on the left-hand side, to the purely virtual environment on the right-hand side. In between, we see every mix of the two extremes, which we call mixed reality. When we go back to the previously introduced example, we can classify the position of the bystander on the continuum to be in the real world, here the yellow dot, and the position of the VR user in some form of immersive VR, here the purple dot. When the bystander starts to engage with the VR user, we can talk about cross-reality interaction. To better understand this interaction and problems that arise from it, we conducted a literature review. We started our systematic review by looking at relevant papers from the last 5 years and considered 5 relevant conferences and the keywords listed here. From the literature, we derived social settings that are mainly in focus of the conducted research. These are private settings, semi-private settings, like work and school, and public settings, for example, plane flights and public transportation. In private settings, the VR user and bystanders know each other, for example, when a group of friends plays a VR game. The fact that all persons know each other has an influence on their interaction while being immersed in such games. In semi-private settings, for example at work, the likelihood that people know each other is very high. Users that are immersed in a virtual environment do not have to expect negative influences from the real world. When collaboration is needed, cross-reality interaction is even desired. Public settings became more relevant as settings in which people experience digital realities. Here, users and bystanders likely do not know each other. If one uses virtual reality in public settings, it is difficult to judge who is around the user, and also immersion could be lessened due to external interruptions. Still, here there are various use cases like improving travel experience on long distant flights. While we are studying scenarios from related work, we derived 3 different research scenarios in which the relationship between users and bystanders differ. Through isolated experience, users can detach from the real world. For example, in a noisy office environment, with a lot of visual elements causing distractions, a virtual environment may be a good idea to isolate from these negative influences. Still, bystanders might cross the area of the VR user. Sometimes it is desired that the bystanders are included. That, for example, can be accomplished using a cave environment, attaching displays to the HMD, or using bystanders to provide haptic feedback, which enriches the virtual experience. Bystanders could also be included to foster collaboration. For example, if a user is solving a task in virtual reality, a bystander could be included to the experience to help the user. A more playful scenario would be a virtual reality game in which a VR user and a bystander are involved in the same activity. To more formally classify the previously introduced scenarios, we can use the Reality-Virtuality Continuum. The distance between a user and a bystander on the continuum can be used to illustrate the relationship in different scenarios. For example, during an isolated experience, the virtual reality user is far away from the bystander and no transition on the continuum from either the user or the bystander is happening. When we include the bystander into the virtual experience, there is a unidirectional transition which brings the bystander closer to the user on the continuum, while during collaboration both the user and the bystander are transitioning towards each other. We now want to suggest research opportunities referring to the previously introduced settings and scenarios. First-generation VR and AR devices are designed for single-user experiences, but designing devices that foster the interaction between user and bystanders can be of interest. New technologies might allow transitioning along the continuum smoothly. That would allow a user and a bystander to interact by gradually transitioning into the reality of each other. Finally, researchers might face challenges while investigating mixed reality scenarios. Tools and frameworks might help us to describe and analyze these scenarios to understand the interplay of involved users, objects, and environments. We're looking forward to discuss these research opportunities with you during the workshop, and thank you for the attention.
Hello, ladies and gentlemen. I am Minas Katsiogalis, and I'm the presenter and one of the authors of Founder's Mobile Augmented Reality for Coastal Erosion Visualization based on geographical data. This work is a collective effort, and I would like to mention also my co-authors, Dr. Lemonia Raya and Dr. Katerina Magna, for their invaluable contribution. Mobile augmented reality, or MAR for short, is still an open research area due to the continuous upgrade of the smartphones that provide powerful platforms for supporting augmented reality. Our initial goal was to create an on-site mobile augmented reality for the 3D on-site visualization of the future. The visualization of potential environmental changes is a powerful tool for public understanding. Landscape visualization can be particularly effective when communicating future changes to the public audience. Combination of landscape visualization and MAR can offer the ability to experience future changes to the environment as if happening now. The phenomenon this paper focuses on is the erosion of coastal zone and the tremendous changes of the coastline across the Mediterranean Sea. The coastline is the physical line where the land meets the sea. Nowadays, coastline extraction and tracking of its changes has become of high importance because of global warming and sea level rise. Our goal was to visualize the shoreline at the specific spot of the island of Crete in Greece in its near future state. Finally, MAR systems of environmental coatings are still rare even nowadays, but we strongly believe that MAR technology on location could raise environmental awareness and provoke environmental action. The MAR system we present consists of two main phases. The first phase guides the user's navigation on the beach, having access to the device's GPS. An area map is loaded based on the user's geolocation. Points of interest are added, guiding the user to where the AR visualization takes place. Once the user arrives at one of the points of interest, the second phase allows the user to experience the visualization after a brief process of calibration. For the AR visualization, a virtual terrain was created based on the shape of the beach at the specific location. Using the terrain, interaction with the water was possible, corresponding to the shoreline. The aerial image that used for the terrain modeling is a real subscale map, exported with ArcGIS software, showing the beach retreat. The model that extracts more accurately the beach at the specific coast area is the equation on the bottom right, which represents the low mean of the beach retreat prediction. The image is showcasing the retreat of the beach in two sea level scenarios. The image was used as a 1:1 scale within Unity game engine in order to model properly the terrain. Planar faces in the real world were recognized based on plane detection, and users' position and orientation in the physical space were tracked by the smartphone's motion tracking. The virtual content appears on top of the recognized physical world. User scans the beach to detect plane surfaces. Once a plane surface is detected, an indicator is enabled. If there is no tracked plane, the indicator disappears. While the indicator is active, the Place Here button is activated too, and the user places the virtual sea content at the pointed direction. User can adjust the virtual content to be in alignment by pressing the settings button. Finally, after the virtual content has been placed successfully, the user can proceed to the visualization. By pressing the two scenario buttons, the visualization takes place in front of him, witnessing the sea to come inland. For your better understanding, a small demonstration video is following, showcasing the procedure of AR visualization. The video is from the camera feed of a smartphone during the test of the application. Firstly, we see the scanning process of the environment. Shortly after, the virtual contents comes to the real world. Pressing the scenario 1 button, the sea comes 3.6 meters inland, while pressing the scenario 2 button, the sea comes 7.7 meters inland. Here we can see the difference in the coastline, comparing the current shoreline in the real world with the virtual one. And finally, user can press the info button on the top right to bring alive the info signs. Signs provide with useful information about the possible outcomes. Thanks a lot for your time. I will be more than happy to answer any of your questions.
Welcome.
Good. Sorry for the glitch at the beginning. I think we are up to discuss the first 4 papers now. I hand over to
your work, even if questions were asked either on Discord or Zoom, we'll repeat them. We'll ask people who ask questions to repeat them again if they are willing to do it live. So people over YouTube will also hear the questions and the answer. So first, Joachim, you asked that you were curious about cross-virtuality analytics, but this was the question that was posted before the presentation ended. So I'm asking if your question was answered during the presentation. Your question was, what is it more relevant in the Milgram Reality-Virtuality Continuum? So cross-virtuality analytics, what is it more relevant?
Yep, that was the question.
Yes, did you get the answer?
No, it would that would be. I've seen the reality virtuality continuum discussed in 3 of the papers. It would be interesting to understand. The authors of the first paper implied that they could go from one extreme to the other, but I wonder if they could elaborate a little bit on that.
Yes. Can you hear me?
Perfectly.
Yes, we can hear you.
Okay, great. So I was the first presenter. And to answer your question, we focus on virtual reality. So we say cross virtuality instead of cross reality. However, we use augmented reality and reality, for example, touchscreen walls or tablets as well, but only in an auxiliary fashion. So we focus on HMDs and VR, but still use the other spectrum, the other part of the spectrum, so to speak.
Okay, interesting. I was wondering if you would consider that collaboration between participants was an issue there, or whether augmented reality would help that.
Yeah, we're still quite early in this project, so I don't have that answer yet, but we are working on it, and we will have an answer hopefully quite soon.
Okay, thanks.
Thank you very much. So the second question was posed by Glenn. In your point of view, how difficult it is to integrate XR with existing display infrastructure, such as public displays, mobile displays, and workshop screens? So I asked the questions. Glenn, if you want to add anything to your question, please go ahead. And I would also ask Andreas to continue with to answer it. Glenn? Do you want to add anything to your question?
That's it. Yeah, let's go ahead and try.
Yeah. So how would you integrate XR with existing displays infrastructures?
Regarding the implementation part, probably we will focus on a Unity-based solution. So from 2D to AR and then VR, we are going to use a client-server architecture, and that will be based on Unity. We can visualize 2D data in Unity as well as rich 3D data as well. Does that answer the question?
Sort of, yeah. My question was not really about the technical terms of how you integrate, but how do you see the existing infrastructure? Is it very relevant to this cross virtuality visualizations, or?
Yes, so you can definitely integrate existing infrastructure. Let's say large touch screens, if you would like to, or maybe tablets even. But again, our focus will probably be on VR HMDs.
Okay, thank you.
The next question was asked by Mohammed. Mohammed, would you like to repeat your question?
Yeah, sure. So my question was about whether, there's a lot of work on, or some work on physicalization, and the idea is to print out visualizations, like figures and graphs and so on. And the advantage of that is that you get to feel how the figures look like and move your fingers around them and stuff. And I was wondering if we can also include haptic feedback in VR and AR applications to provide a similar process of feedback when examining visualizations in VR or in AR.
Yes, our approach is to have a user-centric experience. So if it helps to feel the data, so if you have tangibles, then that would certainly be a big part of it. Again, mostly in VR. However, in AR, I can definitely see the tangibles as well. So not just when you have a completely virtual environment before you, but also partly virtual, partly reality. Yes.
Yeah, I think it could be interesting to see if, like, by holding the controllers, for example, in VR, you could, for example, approach an object and yeah, I mean, I don't know. It's just a curious idea to investigate. I'm not sure if it would work though. So, but yeah.
Yeah, it's definitely worth investigating. Yes.
Thank you, Andreas. And the last question is from Jan. Jan, would you like to repeat the question?
Sure. So I mainly wondered about the type of data that you maybe think is going to work. Well, it's going to benefit from this cross-reality immersive analytics approach. Because I'm not I'm not an expert in the field of immersive analytics, but I think even there people are already trying to find out which type of data benefits from this approach. And now with particularly cross-reality immersive analytics, do you think there's a certain type of data where we say, yes, we're going to solve a big problem with applying here this approach, or do you think it's going to be beneficial in general for every type of data?
We focus on production data. So, for example, fabrics. So you can either touch the fabrics in reality, and then you have a 3D representation of that data as well in VR. And there you can actually see if of course this data is available, where there are potential defects, or you can remodel the data and analyze it as well. So that will be our focus, the production data. I'm sure it also works with all kinds of stuff, but we will focus on production data.
Thank you, Andreas. Did this answer your question, Jan?
Yeah, I'm happy.
Okay, so we have the last question and from Frank. Frank, would you like to go ahead and ask it live, or do you want me to read it?
No, sure, I can do that. So essentially, when I looked at the first paper, there was this nice visualization of information moving from a 2D screen to an AR environment to a VR environment. And it looked very seamless. But practically speaking, when you actually are building these kind of systems, aren't you in the end always in one environment as a user?
Hopefully in the future that won't be as distinct, but more it's seamless, and also seamless fluent transitions. So right now I would have to say yes, it is a little bit distinct and separated. But what we envision in our project is to have a seamless and fluent transition between the different steps of the virtual reality continuum. And in the end, what we would like to have is to, for example, seamlessly combine an expert group with another expert group that is co-located. They can be, for example, in a completely different room or a different country, and they can visualize the same data as the other group. That would be our goal, so to speak.
Did that answer your question, Frank?
Yep, thanks.
Yeah, so my concern here is when you have multiple people using multiple, so you're talking about transitioning from one system to another on this virtuality continuum, but when you have, so that your last sentence really clearly showed this problem, when you have people working in different systems on this virtuality continuum, they also have a different view on the same data. So how does that affect the collaboration between different people working in immersive environment is also a good question, a good point.
Yeah, we will be also investigating, of course, visual awareness cues, so that one group of people can see exactly where the other group of people are looking at, or where they are modeling the data, for example. So visual awareness cues is one very big part of this project.
Okay, thank you, Andreas. So
Matthias, I think you're muted.
I apologize. So let's move to the second paper, Sound 2121, Cross-Reality Transitions Between the Real and Augmented Sound Landscape. I have a question. So the authors are exploring, well, I'm one of the authors as well, but you're exploring sound-only landscape and transitioning between environment sound and internally streamed sound to your chip. Would this change if we add visual elements from VR to AR and transition between these systems? For example, in VR, we might have sounds from the real environment. We might also have sounds from the virtual environment and streamed sounds as well. So do you see additional problems when we add different virtual worlds, also visual clues on this continuum?
Okay, thank you, Matthias, for that question. So I think that's a very interesting take on the paper. And while it was mentioned in the paper that it would be interesting for the computers and for systems to be able to distinguish the natural noise. Is it okay for me to call it natural noise or environmental noise and the noise coming from the virtual augmented reality? I think it's an interesting problem that can be addressed, because the challenge that we're trying to pose from our paper is how do we actually enable the transition between that, because these are things that pose some actual challenges, especially towards safety. And I think it's something that we may not fully understand well, but maybe there are some people here in the workshop who may have some ideas on how to actually distinguish these differences.
Oh, thank you. Thank you, Jordan, for your answer. I will hand the questions for the next two papers to Glenn.
Okay, so we come to our third paper. It takes two to tango, conflicts between users on the reality-virtuality continuum and their bystanders. So we have one question from Jan Guggenheimer. Jan, would you want to go ahead and ask the question yourself?
Sure. So I think this question already escalated a little bit in a shorter discussion we have here at Zoom. So my main question was that in the literature survey that Jonas presented, I felt that there's a strong focus of including one non-HMD user in the HMD or in the immersed environment. And I wondered if they found applications where multiple non-HMD users were included and if this changed the way that we designed this type of inclusion, right? This type of interaction.
So we did not find research that focused totally on that subject, so that you have a lot of bystanders. So as also in the chat, it was sent, there was a YouTube video for the reverse cave environment. We found that also, and yeah, that's, I think, a good approach, but so I think this is still a very good open question for more research. I sent another paper to the chat, this You Invaded My Tracking Space. I think it's a good start, but it's also, I think, single user or single bystander. So that's under exploration, but going deeper into multiple bystanders, I think, is a good research question. It's still open, and I think you can investigate a lot of different things there.
Okay, thank you. I have another question about your work, and this relates to, you talked about the bystanders and this interaction between bystanders and immersed users. And this reminded me of one very successful VR game called Bomb Defuse. Keep talking and we won't explode. I think this is a very nice example of a situation where you do a cross-reality interaction and create a very interesting situation where the people in the environment, the real environment, were try to guide the guy in the virtual environment to defuse this bomb. So in this case, they use only the verbal communication, and this seems to work really well in this gaming scenario. How would you see other similar situations where this could also work so well? Or do you think such games could be enhanced by also sharing the visuals between these bystanders who are in reality and these immersed users?
So I never played that game, but I think I heard a lot of people talk about it. So I think, if I'm right, you only hear what the immersed user.
The only audio is the only link between the immersed user and the user playing the game.
Mm-hmm.
So my question,
I think this is the thing, or this makes it interesting, right? I think this is desired in.
Exactly, yeah, exactly. That actually it's desired that you are sort of blinded.
Basically, you would be cheating if you would attach a display and show everything, right? So yeah, it depends. I think you can measure how much you can add and still have a playful activity, which is challenging. And basically you could make an experiment where you attach more and more cues to the maybe HMD use displays and everything, and see when the game is not fun anymore. I think that would be interesting.
I see it as an interesting example where you don't want to have all of the cues together, and you just, by removing certain elements between the interaction, cross-reality interaction, you make actually the game work, or the experience really connect.
That's why it's important to know what you want to do in the end. So the scenario has big impact on the modalities you use in the end. So.
Okay, so it's actually the scenario. Okay, thank you. There was another question. Okay, so another question that relates to these XR interactions, it relates to, so if I'm immersed in my environment, I'm immersed because there is nothing from the surrounding bothering me in my immersive experience. So as soon as you start to bring in cues from the surroundings into my reality, into my immersive experience, like these are the walls so you don't hit them, these are the people that are also bystanders, they actually break this immersion. How do you see this as a challenge for actually avoiding the conflicts, but at the same time achieving the goal of immersion?
So we found a lot of work that tries to include these, so the surroundings differently. For example, they are substituted by an object that someone would expect to be in that virtual environment. For example, if you have a wall, the wall could be included into the virtual experience, so that the user thinks, okay, this is in sound of or in line with what I see in virtual reality. That would be good for immersion. but it's not always possible, I would say. So it depends on the. So we have these three different contexts. So in private, in public, or at work, for example. So I think it depends on the surroundings how intrusive the cues from the outside world must be to avoid situations that maybe not that maybe have a negative influence on the VR user. For example, when would use VR in public, for example, on a plane, I want to know when the flight attendees ask me a question or when there is an emergency. So, but in private, I think you can make them more intrusive because it's a safe place.
Okay, thank you for your answers. Does anybody have any follow-up questions on this?
Okay, thank
Maybe
you.
just one addition. I really like the idea that it could go both ways. So even as well from the audio perspective, where you see, okay, what kind of audio information I want to provide to the immersed user and vice versa and so on. In this bystander scenarios, I'm really curious. If someone has looked into this before, like it's more like a selective audio, but also as Jan, Jonas said, what is important from outside, from inside, whatever. So which kind of information is useful to the bystander, for example? Maybe you can even kind of block insulting comments or whatever.
Yeah, to avoid conflict. Yeah. So what is the key that needs to be shared to avoid conflict and everybody's happy? The immersive users, immersive experience, and the bystander. Interesting point. Okay, so I propose we move on to the next paper. So this is the final paper we have in this block. So it's outdoors, mobile, augmented reality for coastal erosion visualization based on geographical data. So there is one question on this. So one of the goals of this paper was to actually inform the public awareness of the importance of this environmental problem, which is very important. And the authors chose to use these handheld augmented reality paradigms to actually try to visualize the effects in place. So my question to the author would be, do you think your approach of visualization could be also very powerful and useful within other visualization techniques? So within virtual reality or within 360 images that are generated for those coastal regions? And if yes, how would you actually build this awareness by allowing these users to communicate? Because we know that awareness is best built when we are actually collaboratively interacting and discussing
it. So yes, for sure, these experiences can increase environmental awareness of the public audience. The main factor is that the public audience should see and have contact with the real world. So a virtual reality approach might not be so suitable for what we wanted to achieve. But 360 pictures might be a good approach for this. If we could somehow visualize the future of the beach in its total, because we visualize the beach and its future state only on some point due to the technical difficulties and due to the AR capabilities nowadays, especially on handheld devices. So if we somehow achieve to visualize the future of the beach in its total, which is around 1 kilometer, if I'm not mistaken, this will be a good approach. But to create a total virtual experience for a real world problem, I don't think it would be a good approach. That's why we wanted to achieve an augmented reality approach, so the people can visualize in the real world how the real world will change in the future. A virtual world misses this specific goal, if you understand what I mean.
Yeah, I completely understand, but I'm going to challenge you now. It's difficult to travel to this beach and actually go there and try to visualize that. So you have to be co-located at the correct place in order to see this visualization. Yeah. So my argument would be: is there any other way how you could actually bring this experience to the users? Because maybe these people have visited this beach in the past. They might have even family photos with this beach. So maybe you could actually use your visualizations to alter their family photos and show them, I don't know, a disastrous, what can happen if this environmental problem continues. This is just one suggestion.
Yeah, you're right about that. Maybe a virtual reality experience can achieve that, but we need to have the real, maybe have a 360 video of the real beach in the VR experience, and visualize on the virtual video, on the real video, I mean in the 360 video and the virtual reality, how it might change. What I mean is to create a total virtual environment. Might not achieve so well what we wanted to achieve, but we could bring 360 video into a VR experience to achieve people to see the visualization across the world. Maybe that would be a nice approach.
Okay.
Maybe that would be the right approach on this one. But okay, yeah, that's right. The people had to go there and see the visualization at this moment. Yeah.
Okay, thank you very much for your answers. Is there any other question for this paper?
Can I have just one quick question? So you use sort of the traditional way of adding digital content around what we're seeing, sort of the classical AR application for perceiving the effects of climate change. This could be N other factors. Have you thought of actually doing the opposite of actually, like you get to a place like Beijing or Seoul, you look up the sky, it's a sort of grayish sky, and you actually don't notice what you're missing until you go to another place where the sky is super blue, and you actually see, oh, actually back home there's this super polluted air that I just noticed now that I left Beijing or I left Seoul. Have you thought of using these MR technologies to have sort of force users to see the current effects of pollution and many other factors that we already perceive nowadays, but the impact of perceiving them is not so powerful because it's just the everyday life of the sky is gray, the UV is super high today on the news, but you actually don't sort of you don't actually have that shock of showing how the city could be if the pollution was much sort of smaller, or sort of focusing probably more on diminished reality and not so much on augmented reality to have the same effect on people.
The question, which is the question? Excuse me, I didn't understand.
So have you thought of going the other way around? So instead of adding stuff, removing stuff. So you sort of
yeah, I see. As at this moment, in augmented reality, it's more easier to add stuff on the real world rather than remove stuff from the real world, because real world is a real world. You can't remove something so easily from it, since in augmented reality, your canvas is the real world. So you have to paint on top of this canvas. Yes, I had some thoughts on removing stuff from the real world. For example, if you want to visualize how the sea would come, not inlets, but outlands, where the sand expands. There you have to remove, for example, sea water from the real world, but it's much easier to just put sand on top of the real water and visualize what you want to visualize. So yeah, I had some thoughts on that, to remove things from the real world, but during the development times, it was much easier and more logical to add things on top of the real world. Maybe as we progress and the technology progresses too, we have occlusion, we have depth understanding on mobile devices, which is something new, which was something new during the development times. Yeah, maybe it would be a nice approach, the opposite one, as you mentioned. But during that time, it was not so easy.
Okay, thank you very much. We are running a little bit behind the schedule, so let's move on to the next block of 4 papers. So Florian, please go ahead.
Okay, just give me a second. Hope this time it works smoothly. Go.
Hello everyone. Today we are presenting our initial ideas on cross-reality immersive analytics for individuals and collaborative work. Our lab has been working on supporting analytics work using virtual reality, augmented reality, and extended reality. Firstly, we will provide a brief intro of some immersive analytics projects done by our lab. The Seismic Information Extended Reality Analytics tool, which is also called SIRA, is an application for visualizing and analyzing geological data within a VR environment. Using SIRA, the user can visualize and compare complex subsurface seismic datasets, such as seismic machine learning results, as 3D data volumes.
ASO Immersive Control Room. The Alberta Electrical System Operators ASO operates and manages the power grid in Alberta, Canada. In collaborations with ASO, we developed the ASO Immersive Control Room, an extended reality application that explores how information from the current control room can be replicated and reimagined in a virtual environment.
The Tower of Saliency visualization aims to create a black box of deep neural networks. In our study, we have AI players based on a convolutional neural network playing the game Bomberman against each other. Each decision that the AI players made is transformed into a saliency map. The saliency map of each step are stacked above each other to make the final visualization.
Epilepsy Pre-Evaluation Space EPIS. EPIS aims to help physicians to faster and more effectively pre-evaluate epilepsy before a resection surgery. It highlights where a seizure is occurring and how it propagates through the virtual brain generated from the patient's MRI data. Okay, I hope you enjoyed our prior works in this field. As you know, CR is a new research area with plenty of unknowns, creating immense research opportunities. In this part, we want to introduce a couple of research directions that we want to investigate at our lab. A previous study shows that workstations with more monitors could potentially increase productivity for analytics work. We want to investigate how to move information from a two-dimensional monitor to a three-dimensional space and back in order to overcome the limitation of the number of the physical display. We will conduct case studies to explore what visualizations should be moved to 3D AR space to support individual and team collaboration. We will also investigate how users want to interact with CR applications. We will conduct an elicitation study to investigate how individuals and teams want to interact with the CR system with natural gestures intuitively. We hope that a common set of gestures and interactions will materialize so that toolkits can be developed to support them.
In addition, we want to explore mixing analytics data collaborators with different systems working in the same extended reality space. Particularly, we are interested in studying how collaboration works out when some participants are using AR while others are using VR spaces. Also, we will conduct studies to explore how to present user-specific perspectives on shared information while users are in different locations in a virtual space. We would like to investigate how far can virtual representations deviate from intuitive physical norms without hindering collaboration, and how we could enhance collaboration by unsharing visualizations of information. In the long run, we would like to develop engineering guidelines to provide evidence-based advice to developers on how to design CR applications and which kind of data should be presented on specific places of the virtuality continuum. That brings us to the end of the presentation. I want to say thank you to our colleagues who provide videos of immersive analytics projects, and I sincerely appreciate your interest and attention.
Hi, my name is Jihei, and for this workshop, we are presenting our proposal, The Body in Cross Reality, a framework for selective augmented reality visualization of virtual objects. So, what is cross-reality interaction? It's an emerging field within human-computer interaction that investigates how users of different realities can interact with each other. These realities referring to the real environment, the virtual, and anywhere in between. However, for users of different realities to interact with each other, they must first be aware of each other, which involves both an expression and perception of information. We are interested in the cross-reality interaction between a VR user and an AR user, specifically how the VR user can express information through action and gestures, and how an AR user may perceive this information. The question then becomes how much and what type of information is relevant for clear and effective communication. Action and gestures inevitably involve the body. The AR user may be interested in what the VR user is seeing, how the VR user is interacting with the virtual environment, and where in the context of this virtual environment the VR user is going. Especially with the rise of mixed reality technologies, immersed users can interact with the virtual environment through increasingly more creative and complex means, creating an importance of understanding the body in relation to the virtual world. Thus, we propose a framework for selective augmented reality visualization of virtual objects to augment the external user's view of the VR user one-to-one scale with specific elements from the virtual environment. It's based on a simple concept where some objects in a virtual environment are visible to the AR user, whereas others are hidden. So 3 criteria determine what is visible and what is hidden. Firstly, proximity threshold, which shows a radial distance of volume around the VR user to the AR user. Secondly, field of view, which shows a slice of what the VR user perceives to the AR user. And finally, importance ranking, which shows a selection of predetermined objects to show to the AR user depending on how relevant the object may be according to the scenario shown. And we can follow this framework through an example, such as food handling training between a VR trainee and an AR supervisor. Here we see a view from the real world with an immersed VR user and an external user who clearly has no idea what's happening. But the VR user can see the full extent of her virtual environment perhaps the entirety of which may not be necessary to visualize to the AR user to communicate what she is currently doing. Thus, the framework looks at selectively augmenting virtual objects such as food items and equipment in front of her to the pink AR user. This looks at two criteria in our framework, proximity threshold as well as the importance ranking. Another example beyond food handling could be exploring an architectural exhibition, in which case it may be relevant to select both the criteria field of view to show where the user is looking at and what she is interested in, as well as proximity threshold to limit the boundaries of information being visualized. So what are our next steps? They would be implementing, experimenting, and evaluating the propositional framework across use cases. We would like to simulate a use case between an AR supervisor and a VR trainee, where we investigate the understanding of the AR user regarding the VR user's actions. We would also like to evaluate the usefulness of the proposed three criteria against each other, as well as baseline conditions, such as an external user that can see the VR user without AR, and a VR spectator that can see the entire VE without seeing the VR user. And finally, taking our first baby step forward, we have our mock-up for the second criteria, field of view, where only the virtual objects in front of the VR user are visualized to the AR user. So on screen, that's my colleague Rob, who has worked on his proposal with me. And that concludes this presentation. Thank you for your time.
My name is Jeremy Meyer, and I'm studying a Master's in Media Innovation in the Netherlands. People tended to say, "I understand you," when I told them about my situation or how I was doing. Back in May 2012, I had a severe brain stroke. I got visually and physically impaired. I got stuck fighting my losses, of course, not recognizing my gains until years after. Especially within society, I felt left behind. For my master's degree, I started researching the topic of empathy, which brought simulations to the front, and not much later, problems in healthcare. Healthcare, of course, became quite a familiar area to me by now. A decrease in empathy is a major issue within healthcare curricula, fostered by stress and burnout among healthcare students and providers. Mainstream thought in the 20th century viewed empathy as a detached concern with medicine, of purely intellectual form at best. Engagement with the patient's emotional needs is not necessarily viewed as a core aspect of care. The ways in which empathy of medical students fluctuates during the years of training is a topic under constant investigation, and multiple studies find it to decline, especially during the phase of clinical training, resulting from overcrowded institutions or the complexity of clinical practice, exposure to experiencing depression and anxiety, and often students find themselves in need of support, which tend to cause a decrease in empathy. Given the importance of empathy in the provision of healthcare, the topic of empathy training in healthcare trainees in personal at all stages is one of particular significance. In experiential learning, learners are not restricted to a passive role, but processes exist where learners are directly involved in the experience and reflect on it. Simulations can provide a pathway for such experiential learning to occur. In the context of disability, however, certain designs that disable participants have been criticized for focusing on negative experiences and what people cannot do, rather than simulating a functional disability experience. Unintentionally, they increase the perception of otherness in the disabled, and charge interactions with the disabled with feelings of anxiety and threat. So simulations focus on personal deficits, impairments, ignoring the picture of disability in social settings. However, experiential learning simulations that do explore disability in society can provide another insight into disability, allowing the participant to become aware of the social dimensions like bias, stereotype, and interaction strain. Not even talking about physical barriers yet. Even briefly enacted, these experiences allow the participants to learn more about themselves and the social construction of disability within society. To gain some true insights about what it means to live in society with a disability rather than to live in one's physical environment with a disability. The intervention conserves a wheelchair slightly lifted from the ground, instrumented with sensors, rotary encoders, to feed information about wheel rotation, movement, into a virtual world. Next, through tactile actuators, tactile information will be transferred from physical world into the virtual world. Because according to former research, the sense of embodiment has an underlying structure consisting of three subcomponents: sense of self-location, sense of agency, and sense of body ownership. Sense of body ownership increases by the degrees of sensory correlations between biological movement and perceived stimulation on avatar's body. A randomized between-subject research design will evaluate the effects of disabled agency in VR. The independent variable will be visual-tactile interaction, representing agency. First, visual-tactile interaction correlations will be present, allowing interaction with the environment, causing more independency. Second, visual-tactile correlations are missing, causing dependency on the social environment, emphasizing constraints and barriers. Initially, levels of empathy among Dutch healthcare students will be evaluated through a chosen questionnaire, all with the goal to explore the answer to this fairly personal research question.
Hi everyone, my name is Ana Oliveira and I'm going to present our work about using a VR field studies to assess the effects of visual and haptic cues in the wild locomotion. Walking involves balance and coordination of muscles, so any deviation from this is considered a gait disorder. These disorders have various causes such as age, strokes, Parkinson's disease. Our work was primarily motivated by Parkinson's disease because as this disease progresses, many are the effects in patients' ability to walk, as it can be seen in that video. There is no cure or treatment that completely addresses the effects of Parkinson's disease on gait. However, these symptoms can be minimized through cueing. There are three major forms of cueing: visual, auditory, and haptic. Visual and auditory cues are the most used and studied types of cues. However, gait normalization had been shown while using the three types of cues. And although many studies have demonstrated the effects on patients' gait inside the lab, very few studies demonstrate the effects out in the wild. In fact, we may say that visual and auditory cues are hard to produce outside the lab and are likely to lead to a cognitive overload and distractors, whereas haptic cues are proven to be less cognitively taxing. Therefore, our work will focus particularly on haptic cues. The main objective of our study is to understand the effects of various stimuli on patients' gait, attention, and safety, especially when used outside the lab. In order to do that, we had used a VR street with three different distractors: a car, a pedestrian, and a crossing light. During the simulation, we will be measuring gait parameters such as cadence, step length, and velocity. We are also going to be measuring gait parameters such as the hits and the dwell time at the distractors, and usability parameters through a SUS and a preference questionnaire. So now, what are the stimuli that we used? A classic approach is to use visual cues. These are bright traverse bars on the floor. In our study, the distance between the bars is equal to 150% of the step length measured during baseline walk. Another classic approach is haptic one pattern, one watch, which is represented by a single vibration on a wrist, only giving the participant temporal information. In our study, the cadence of the vibrations matched the cadence from the baseline. A novel approach is haptic one pattern, two watches, represented by a simple vibration played alternatively on the right and left wrist, indicating to the participant how to map the vibration with the corresponding foot. The last stimulus used was haptic two patterns, one watch, represented by two vibrations patterns on one wrist, being each vibration patterns mapped with a foot. Once again, it is important to refer that our main objective concerning gait is to improve it. This means less but longer steps. Therefore, we aim to get an increase on step length and velocity but a decrease on cadence. And despite the fact that all our participants did not have any gait disorder, their gait seemed to suffer an improvement during haptic cues. For example, regarding the step length during visual cues, it was noticed a great reduced in contrast to an increase during haptic cues. Cadence was improved in all cues, however, greater improvements were noticed during haptic cues. Regarding gaze results, as expected, visual cues had significantly lower numbers of hits and dwell time, meaning that when submitted to this, participants seemed to not be aware of the distractors around them, creating a possible discussion about security when using these cues outside the lab. On the other hand, during haptic cues, participants were clearly more aware of the surroundings, being the number of hits and the dwell time during these cues similar or superior to the baseline. In line with this, the results from SU show that participants in terms of usability found haptic cues in specific haptic 1P, 2W more easy to use. When asked about what was their most and least favorite cue, all participants agreed that visual was the least favorite and haptic 1P, 1W was their most favorite. After this study, we observed that even though this was performed only by healthy people, haptic cues were not only more efficient normalizing gait, but they also showed to be more safety to use outside the lab. We aim to explain this work by performing this study on actual participants with gait disorders and by creating a wearable application that can help address gait disorders in a comfortable, usable, and safety way.
So I hand back over.
Yeah, I'll pose questions for the second two papers, and then Clem will will ask questions for the second two papers. So basically, the first paper we have is individual and collaborative cross-reality immersive analytics, initial ideas. So if you have anyone who has a question, please go ahead and speak. If not, I have a question about your paper. So you present 3 research questions in your paper. The first one is, how can we support analytics work by moving visualization across the Milgram continuum? The second one was, what interactions do users naturally use for cross-reality applications? And the third one was, how does control over a shared reality impact team collaboration? So my question is, do you have any hypotheses about these 3 research questions in mind, or any studies that might answer these questions? So have you thought of these studies that might help you to answer these 3 questions?
Eric, do you want to go first?
Yeah, go ahead, Frank.
Yeah, so essentially, there's a lot of questions around cross-reality interactions. However, when I look at it, I think the most interesting thing is actually really looking into how can we actually benefit from unsharing experiences. When we interact in the real world, we have an intuitive understanding of what people see and what they do with what they see and how they react to it. When we are in a virtual reality, even in a collaborative setting, we can actually break that intuitive understanding. We can actually create a reality that looks different for you than it looks for me. This initially is obviously creating lots of problems, but it also creates opportunities. When I look, for example, at text, and you look at the same text from the other side, you might not be able to read what I'm reading. In a virtual reality environment, we can actually change that. We can actually present information so that it's accessible for both of us. So the studies will actually be looking into how can we actually benefit from this unsharing of experiences. Text is an obvious thing, but what about if we have immersive analytics and visualizations of data? Does it actually make sense to actually change perspectives?
Thank you. So does anyone have a question about the second paper? The second paper was titled Individual Collaborate, the Body in Cross-Reality Framework for Selective Augmented Reality Visualization of Virtual Objects. Before we continue, we only have 3 minutes left to the break, so I propose we really go quickly through these questions, and we move the conversation online. So there is a link in Zoom to Discord that was posted by Joachim. So please follow that link and we can continue the whole conversation online. So does anyone want to pose a question for the second paper? I know that Katerina Fidalgo already posted a question and Jiahe answered it. So we can leave it there. We'll also put these questions online on our website for you to check later, for everyone that's on YouTube that might check this later on. So if anyone has another question for the second paper, otherwise we can move to the third one.
I had a remark for Frank Morer. That's an interesting question that he raises. Indeed, we have done experiments in my group regarding this idea of being face-to-face but sharing the same perspective of the data. And we have a couple of interesting research results there where people reported that they felt more immersed or more related to the subject of this course that they would feel in the real world. So I would be happy to discuss that with you, Frank.
Happy to talk about that.
Okay, so we have 2 other questions over on Discord. One is from Hawa. Would you like to go ahead and ask the question, please?
Yes, thank you. So thanks for all the great talks. My question is for the paper, The Body in Cross-Reality Presentation. So you mentioned that you're sort of trying to identify the VR user action and based on the VR user action to filter out the content for the AR user. So my question is like, so what type of actions that you're actually looking at? Is it the gaze pointer or the gesture? So are there any particular actions of VR user that you're aiming at to recognize when filtering the content?
So we imagine this to be quite case specific in terms of, well, for example, if there was a bar scenario where you have a VR trainee and an AR supervisor, then you would have the VR trainee, like, bartender in training, go through certain actions for how to make cocktails, for example, and then the AR trainer would get a checklist and would observe these different actions that the trainee is doing. And if there are several mistakes during these actions, then there'd be a checklist of noting down these. And then later you would look at how well the AR supervisor kind of observed this trainee in terms of how well the AR trainer could understand the situation using that one. And of course, the varying degrees. Likewise with the proximity threshold, so a certain area around the VR trainee, as well as selected objects. So maybe you just want to show the glasses or the bottles that the trainee is holding at the moment and nothing else in terms of how relevant information may be according to the scenario. Does that answer your question?
Yes, thanks a lot. Thank you.
Okay, thank you. Let's move to the third paper, which will be created by Glenn.
Okay, so we are already over time, so we're going to do one quick question per paper, and like Matthias said, do the rest of the discussion online. So if we move to the third paper in this session, exploring visual-tactile embodiment in a social virtual reality setting with a physical wheelchair for training empathy towards social disability barriers. Do we have a question for this paper? Okay, I have one quick one. So in the presentation, you talked about empathy and about how you want to actually create systems that will train for empathy better. You mentioned you use questionnaire to evaluate empathy. I'm interested in what kind of questionnaire you plan to use to actually really see how well your systems perform.
Hello? Can you hear me?
Yeah, we can hear you.
All right. Yeah, the idea is for the research. Yeah, I've seen quite a few different empathy measure questionnaires, or instruments. And yeah, some are validated and some are not, and there's quite a discussion actually. But yeah, we were intending to go by means of the empathy quotient. I'm not sure what's the author on that. I'm sorry, but yeah, there are quite a selection of 4, I think. But yeah, we'll have to select one that's correctly validated, I suppose.
Okay. Thank you. So thank you for this quick response. Let's move on. So if you have any more questions about this publication, please ask later on Discord. And we move on to the final presentation, using a VR field study to assess the effects of visual and haptic cues in the wild locomotion. So do we have a question here from the audience? Okay, so if there is no question, I have a quick one. So you made your evaluations on people without gait problems. So my question is, do you expect, when you run the real evaluation on people who have gait problems, do you expect your results to be more conclusive or less conclusive when you compare them to baseline?
Hi, do you hear me?
Yeah.
Yes, it was not possible yet to perform the study on actual patients with gait disorders. However, up to my knowledge and regarding when comparing this study to previous one in related work, yes, I think it will be more conclusive, since the gap between the baseline and the measures while using the cues will be bigger, so it will be easier to compare. But it's just speculation. I don't know yet.
Okay, thank you for this quick answer.
Maybe I have a quick follow-up on this. Yeah. So do you expect also, what do you expect how patients will actually react to wearing a headset? Because I think in this kind of target group, that might be also a crucial thing.
Well, it has been done various studies using VR technology, augmented technology. So it has been done with that. Patients normally react like it's not easy like it's easy for us without any disorder. But well, I don't know, but I think they will react well to the VR, and it's quick. It's a quick simulation, so they just have to walk like 5 meters for us to measure what we want to measure. So it's like each trial, it's about like 20 seconds, not even that. So Yes, I think they will react well to the VR. I think that was your question.
Yeah, of course, sounds great.
Okay, thank you very much for your answers. I'm sorry to be rushing you, but we are behind schedule. So I think we should conclude with the talk. So big thanks to all the authors for their presentations and for all the questions from the audience. Now the question to the organizers: when do we start our keynote speech? Because it should start 2 minutes ago, and we didn't have a break yet.
If Anasol doesn't mind, we should just have a break for everyone to grab their coffees, and then if Anasol is okay with waiting 5 minutes for everyone to reconvene and stretch their legs, is that okay?
Yeah, perfectly fine for me.
Great.
So
okay.
2:45. So 2:45 we start.
2:45. Yeah, I think that's okay. We always knew this plan was too good to be true. I also want to say thanks to